According to the clock. Okay, great. Hey everyone, let me drop the agenda here in the chat. So this is mev-boost community call number 11. It's been a couple of months since the last one. So yeah, I'm glad to see you all. And yeah, let's just go ahead and dive in. So there's a few things on the agenda. Yeah, I guess we'll just go in order here. So I did want to touch on an incident we had with the Titan relay and possibly also box route from what I saw. There's essentially an outage with, I think there was ultimately like a state route mismatch between the builder and the relay. And let's see, I don't know if anyone from Titan is here. They might not be. So yeah, in any case, there was a postmortem. I think generally everything's been resolved, other than the fact that there was a period of yeah, some number of missed slots on mainnet, which is not great. But yeah, there was some, my understanding is that there was some issue with optimistic relaying. I think basically something inside their infrastructure had an issue with load, and then basically they didn't detect the like failover as like some issue to demote builders when they should have an optimistic setting. And because of that, yeah, there are a number of missed slots. I believe they've compensated the proposers, which is sort of the guarantees of optimistic relaying. So it's all been sorted, but yeah, definitely something to keep in mind. So given that I don't think anyone from Titan is here to say any more, we will move on to the next item. And yeah, so the next thing here is BuilderNet. I grabbed the blog post here, and yeah, I see Shay's here, some other people from Flashbots. This was a pretty exciting announcement they've had in the last couple of weeks. I don't know if you guys would like to say anything else or provide an overview of BuilderNet.
Yeah. I put together like a very short slide, just in case it's useful for people. I'm guessing most people here have some familiarity already with what it is, but I thought we could just say a few words about what it's about and some questions or things that I think will be relevant to the crowd here, and also just some time for people to ask questions and jam on it, if that sounds good.
Yeah, sounds great.
Cool. All right. Can you see this?
Yep.
Beautiful. Okay. So, as a quick TLDR, if you've not seen the BuilderNet announcement, basically, really high level, the problems we're trying to solve are censorship and exclusive order flow, and generally running centralized infrastructure in block building. With BuilderNet, the goal is to make a block builder that is censorship resistant in the aggregate and shares its order flow with a bunch of different parties, builders, searchers, etc. And one important note there is it's not supposed to replace builders and searchers. It's just supposed to handle a bunch of what I'll kind of call the boilerplate and BD that goes into block building today, so that basically everyone can just focus on things like building great software and finding alpha and not on, order flow acquisition, and they just get paid for their contributions. And the other explicit goal here is that Flashbots doesn't have a position of control in the system. We're taking steps already in this direction by having two other teams operate it with us right now. And we're also doing a lot more over the next year. You can see our roadmap to completely remove centralized dependencies for everything from storage to the way that we do T governance. We really want to get rid of those dependencies. And so to that end, we want to build this in the open. There are a lot of things we haven't built yet. It's very early. So for example, the system is still not ready to handle tons of operators, but all the code and the docs and the roadmap are out there. And we want to bring people in as early as we can. So that's a reason for sharing some of this today. And the final thing I just wanted to note is a few things that I think folks, especially on this call, might be interested in when it comes to BuilderNet. So for builders, we right now are in the process of speaking with, we've spoken with basically all of the top teams, and Beaver build is kind of the furthest along. They're actually running their builder in a TE right now, trying to get some benchmarks, and other teams are starting to explore the idea. And our hope basically is that if we figure out how to kind of integrate Beaver into the system, that will be a good blueprint for other builders to integrate. So right now we're kind of focusing on that case study and then trying to bring those findings to other teams next year. On the relay front, BuilderNet uses relays just like regular builders do. And one thing we're super conscious about is keeping this neutral. We started submitting just to like a small number of relays, but we also have gotten requests from other teams who want to be connected. And we're trying to figure out how to do this while maintaining some of the security requirements that our users expect, because security and privacy are kind of the core value props, or some of the core value props of BuilderNet, of TEs. And so one idea we're kind of tossing around is to create something like the fair market principles that we use to share mev share flow. So taking input on what that could look like. And then finally, on the mev-boost front, we've already been publishing a few ideas. I think we've talked about TE-boost on this call before, ways to upgrade mev-boost to take advantage of some of the R&D we've been doing in BuilderNet, and maybe even remove the dependency on centralized relays in the future. And we think that BuilderNet will hopefully be a good test bed for these ideas, and we can maybe use it to test them without enshrining a single builder. Since we last talked, there's actually been a couple interesting ideas and contributions in the TE-boost land. There's an idea about how to solve data availability with this new encryption technique. I'm interested in validators who want to test out TE-based sidecars. So continuing the R&D next year, and definitely welcome input from folks on the validator and relay side. We're also looking into things like pre-comps, which I think we'll talk about later. But yeah, just wanted to give like a very short, what's it about? Some things I think might be relevant to this group. But on that note, I'll pause and see if there's anything specific we want to talk about.
Cool, thank you. Yeah, I have a number of questions, I guess. You touched on this, but like, so right now it seems like with respect to a relay, BuilderNet just looks like another builder, right?
Yeah, today you can think of it just as another builder.
Okay. And then, yeah, then you mentioned TE-boost, and my understanding is that was essentially, one way to think about it is putting the relay in a TE. And so I wonder if there's like some, does BuilderNet expand and like basically just have more and more of this pipeline inside TEs? Or yeah, how do you have any sense of like how they could interact or relate?
Yeah, putting relays in TEs is one interesting angle. The other, I think one thing also TE-boost specifically is trying to do is figure out if you don't need like a centralized service in the middle there. If you can use a TE proof for integrity, if you can get privacy from the builder itself, and then if we have ways to solve for things like data availability and ways to multiplex between BuilderNet and a lot of validators in the limit, maybe you don't even need to run an extra piece of software there, or maybe that piece of software looks super different from what a relay looks like now. So both kind of first principles, thinking about what a relay does, what the guarantees are, and how we can just replace them without a centralized intermediary, is I think one line of research that's for some of these encryption techniques have been interesting. There's also things we could explore, like putting the relay itself into TE. I think all things are on the table right now, and we're talking with people on a bunch of different fronts who are interested in different parts of it.
Very cool. You mentioned something about TE governance. Could you speak to that? Like, I think my understanding is that all the stuff's using TDX, and then like, is there a question of like different TE providers, or yeah, I guess are there other like governance questions to think through there?
Yeah, so one thing that's interesting, and Chris might have more to say here, but one thing for as an example of what that can mean is the expected measurements. So like all the operators in the system are required to run specific code, and the measurement is basically how you like identify what code they're running, and how do you decide like which measurements are allowed in the system? How do you update that list? Questions like these become kind of interesting. Chris, I don't know if you have any other things to add to there, but that's like a concrete example of what we might mean by that.
Yeah, absolutely. I think one key point is deciding which software is eligible to run as BuilderNet nodes and to have access to all of the order flow that's inside, because all BuilderNet nodes share all the order flow with each other. So each builder node sees all the order flow in the current architecture. And of course, for upgrades as well as for deprecations of old software, there needs to be some registry of allowed measurements. And these measurements, they represent exactly the software versions and the configurations that are contained in a given TDX image, and governance over these. That can start with very simple setups like a multisig that may include like auditors signing off on specific measurements that, after having audited the relevant code bases, could be an interesting direction. Keep in mind that all of these TDX images, TE images, they are all reproducibly buildable. So anybody can run the whole build process and arrive at an image with the same measurements. This way, anyone can verify the specific state of the software and configuration that is running in any given BuilderNet node. Yeah, that's
Okay.
I think what I have to add right now.
Yeah, nice. Very cool. Maybe zooming out a little bit, like I guess I'm curious, like how do we think about builders and searchers in a BuilderNet world? So my understanding is that there are operators in BuilderNet. Are builders operators, or is it more like as a builder, I kind of have my like say, let's say I'm like much better than someone at like block packing. And so then I could come to BuilderNet with like my code and then offer that to the system. And then as a builder, do I run my code in the TE, or is there like a different operator set that's sort of running the network?
Yeah, so I'll explain like how it looks today and then how we're think of evolving it over time. So today there's just a single piece of almost fully open source. Well, there's fully open source merging software, and we have a couple like auxiliary private sidecars that handle a couple things like bidding. But there's basically this one big open source chunk of software. Every operator runs it. It's fully open. You can attest exactly what they're running. You can check it against our build a code base, et cetera, et cetera. That's what it looks like today. Fairly homogeneous, all open source. Operators are just kind of parallel copies of each other. They're just building blocks in parallel, with different preferences on the edges. On a kind of like short to medium term time horizon, we have been experimenting over the past like 6 months, maybe longer at this point, with ways that you can securely run private code in a TE, with some kind of like restrictions around ingress and egress, so that you could, for example, you imagine the next natural evolution of the system would be we still have these kind of open operators, but they might take a specific operation like searching for arbs at the bottom of the block, or maybe a specific kind of part of bundle merging. They send some information into this secure environment where some private code, maybe it's a searcher, maybe it's a proprietary algorithm from another builder, does something to it and sends back a result that's enriched in some way. And there's probably some economics that make it so that those private programs can kind of monetize their contributions. So you can imagine it evolving into this sort of open source core that's starting to outsource things to private programs, as like the next natural step. And there's a couple specific use cases we've been experimenting with there. Then if you look further down the line, I think it becomes interesting what the line is between these things. Especially we want to do things like distributed or partial block building. So somebody builds part of a block, somebody extends it. Maybe some of those parts are open, maybe some are private. I think where the boundaries really matter is where user guarantees come in. So like if there's a really important guarantee about the way bundles are processed, or ordering for order flow options or something like this, we want to make sure order flow providers get the guarantees they want. But we're trying to find ways that you can insert lots of kind of proprietary code in that process. So it'll probably look more like a mix over time, but that's kind of where we're starting from and how we'll probably evolve towards that state.
I see. Yeah. So like, you could imagine as a searcher, I could come to this thing and like my code is, blind in some sense. But then there's like guarantees via the TE and like the trusted execution that maybe I only have access to like, parts of the transaction or things like this. Or like maybe some part of the block, and then I can kind of constrain my behavior in other ways.
Yeah, I'll actually, if anyone's interested, this is the latest write-up. I'll put it in the chat. Where is the chat? Ah. That's an example of the architecture just in there.
Okay, cool. I don't know if anyone else has any questions. I was just asking a bunch.
Yeah, I have a beginner question, but how would you attest that a TE is running like some specific code with constraints without that code being public?
Yeah, so the attestations are mostly for open source code. And I'll also see if Chris wants to say anything in more detail, but high level answer is what we're able to do is like create specific firewall rules and control like what goes in and what goes out. So you can kind of imagine you're like outsourcing a super specific function. You have some open source code that defines like what role, what job you're outsourcing, and you have some environment you can basically guarantee you're sending data into and that data can't leak, and you know that somebody can only send a certain response back to you. We can have like those kinds of guarantees, even if the code inside the secure environment itself is private. So there's attestations are like one tool here, but there's also other ways we can actually constrain the environment itself and use those properties to get kind of restrictions about what the private code can do, more on like what it can intake, what it can export, than what program it's actually running.
Yeah, the way I'm starting to, oh,
Got
Chris,
it.
go ahead if you had something to add.
I just want to say I don't really have much to add. I think you covered it pretty well. Yeah, the sandboxing techniques from just sandboxing binaries or containerization into like VM type of sandboxing that you only expose custom opcodes. And on the other side, for the attestations and the measurements, it depends how you load these custom functions. That can be from including a binary that is known, that has like a known hash that is pinned, or like downloading dependencies dynamically. There is a bunch of ways, but yeah, the sandboxing part is definitely kind of close to the containerization. And we are working towards generally a pretty containerized setup within the TEE environment, both for security as well as for development velocity.
Got it. Very cool.
Yeah, correct me if I'm wrong, but I guess from what I'm hearing, one way to think about it is it's almost like, well, I think this is kind of how Mev share worked, where it's like you would reveal like selected details about the order flow, and then, from there, searchers and or builders could go and like do their thing. Maybe one way to like another analogy would be like some servers are knowledge proof, or like maybe NPC is like a better analogy, but ultimately it's like you don't know what the code is, but you do know via the TE, like there are guarantees around the inputs. And then, yeah, I guess, the way you set it up is like there's a particular API into like the private code. So like there's only so many possibilities that are even possible. And yeah, then you have to like structure things well so that no funny things happen, which I imagine is tricky, but that's how you could like imagine this working out.
Yeah, I think this is directionally right. I see also the article that Shay posted in the side chat about searching in TDX, which is kind of like related to where searchers can upload their private code into a TDX instance, and it's running in a sandboxed environment there. And then it can also receive, for instance, order flow without having the ability to leak it, basically.
Yeah, one important distinction for the mev share analogy is like in mev share, we're trying to figure out, okay, how much information can we tell people so that they can efficiently backrun without front running people because we leak too much. And one cool thing about this approach is you can just share everything. You're just sending it to the secure environment. You know, the only thing that can happen there is somebody can send you back like a specific kind of bundle, for example. And you know that, you know, the open source builder is only going to process that bundle in a specific way. So you can get much more efficient kinds of searching and outsourcing, which is very cool.
Yeah, okay, that's a good point, because
Got it.
you can constrain not just the inputs, but also the outputs, because then it plugs into the rest of sort of the quote trusted code.
Yeah.
Cool. How do you guys think about like getting order flow into this thing? I mean, I would imagine the argument is that BuilderNet is, yeah, somehow more efficient or better at returning, let's say, mev refunds to users, and then that starts a flywheel where, you know, I send to BuilderNet and it's better for me to do so, and then I just kind of keep doing this, and then, you know, the success story is that over time you kind of, yeah, you have this flywheel, like I said, where you just get more and more into the system. I wonder if there's like any bootstrapping problems that you guys have hit so far, or if you see like difficulties there.
Yeah, it's a really good question. I mean, I think right now the state of the order flow market is just a lot of these sort of custom fragmented deals that don't really always talk well to each other. It's also not super obvious, like actually what each order flow provider's requirements are, because they're like all using kind of off-chain agreements with different providers. And I think one barrier there is just honestly bringing a lot more transparency to what's going on. And this is pretty interesting because, like, for example, some of this information just isn't clear on chain because the payments happen off chain, because that where, for example, you know, which wallet order flow originates from, that's not always clear in the transaction details. So I think this is one thing, which is how do we build a system that, you know, ideally just creates like net better refunds for everybody, which is our intention and what we think the design will lead to. How do we make sure it, you know, works with the specific requirements that every order flow provider has? Because right now that landscape is fairly fragmented and custom. So I think that's one thing we're thinking a lot about. And so I guess one thing that would be helpful there is just bringing more transparency to that space, and also helping order flow providers like understand the options available to them, and get the facts presented objectively, because I think it can be very confusing as like a wallet looking at all of the things that are happening in the MEV space and trying to make an informed decision. And you know, everyone's, you know, competing and trying to sell their product, and this means it can be hard for people to just get like a transparent answer to what are all the implications for how your product impacts my users, how does this actually compare in practice to something like BuilderNet. So I think that's one thing that we're thinking about, and that would be, I think, something as a community we can probably do a better job on. Yeah.
Nice. I would be curious, yeah, maybe one more question, then we can move on. I would be curious, like, how you see BuilderNet helping builder centralization. It seems like an immediate thing is it lowers barriers to entry, because I can kind of just show up with my code and kind of get started. Yeah, are there other things you see, or yeah, I guess do you think that this will help with builder centralization at all?
The hope definitely is that it will help. I think lowering the barrier to entry is one thing. Also, just like letting people focus is another thing. Like right now, there's like large parts of block building that are kind of commoditized. And it would be, I think, a lot more like efficient if everyone could kind of just like focus on their specialty and get paid like, you know, get paid an incentive compatible amount for it. The idea is not to take profits away from people, it's just to let them actually like focus on building better experiences for people, not do all this boilerplate stuff. And I think one piece of the stuff is also like acquiring order flow. That's probably one of the biggest and most frustrating costs that there is today. And so we're hoping we can help solve part of that problem. I think the other thing here that's interesting is like distributing the block building process itself. So in the vein of focusing is specialization. We can, instead of having like one monolithic entity from start to finish, build a block, lots of different people involved somehow in that process, which also has some nice properties when it comes to things like censorship resistance or other things you might care about in terms of reducing centralization. So both making it easier for other people to enter the market and also changing the way the blocks are built so that more people participate in each one of them. I think there are a couple different ways it'll help. Yeah.
Cool. Yeah, very exciting. I guess it's pretty early for BuilderNet, but yeah, I think we'll be looking forward to seeing how it plays out. So for anyone here or anyone who's listening afterward, if I wanted to sort of engage a BuilderNet or get started, like, is there a place I could go to? Like, is there sort of like maybe some docs or a website to figure out how I could engage?
Yeah, we have a website with like a narrative introduction and also a bunch of docs, and I'll just link the how to participate page in the chat.
Cool. Excellent. Okay. Yeah, thanks for that. Thanks for fielding all of our questions. But yeah, it is super cool to see. And I think is like a really interesting use of TEs towards a very big problem we all feel. Cool. So the next thing on the agenda then would be pre-comps in mev-boost. And I think this is kind of a general sort of I guess question for discussion here in the group, so, I think all of us here are mev-boost enthusiasts, in parts of the community in various ways. And something we're seeing come up is this notion of pre-comps. There have been a lot of efforts around different like people in the sequencing space to add pre-comps to layer one. And my understanding is kind of how they're shaping up is to be backwards compatible with the builder APIs and mev-boost that we have today. Then there's essentially like this gateway actor that kind of looks like a relay that handles the different pieces of the pre-comp machinery to give the end user these guarantees. And right now, mev-boost doesn't necessarily support pre-comps, I guess, in the way that people are thinking about it. There have been a lot of efforts here, and I think there's some standards starting to emerge. And yeah, I'm not sure if anyone else has any particular questions or places they would like to take this, but I guess I could open the floor with just, exploring adding pre-comps to mev-boost and kind of seeing what that looks like.
Yeah, we can share maybe a quick presentation talking about the one of the potential standards for sort of making mev-boost compatible with pre-confirmations.
Okay, yeah, that'd be super helpful.
Great, I'll share my screen. Okay, can you see my screen?
Yep.
Cool. So yeah, I'm Jonas from Chainbound, and we're currently working on Bolt. And Bolt is a proposer-centric pre-conf protocol, also focusing on proposer commitments, but right now just including pre-confirmations. And so the setting that we're in right now is that various pre-conf protocols would need some changes at least to mev-boost and the builder API. Alex, the gateway designer you spoke about is another potential avenue, but we feel that it's potentially not a great one as it is right now because there are a lot of decentralization concerns. And so a lot of teams are taking a more proposer-centric approach, which would definitely require some changes. So we have worked on a specific version of this API called the Constraints API. And we basically like to gauge sentiment for it, both like as a standard and to potentially eventually upstream into mev-boost. So maybe first I'll walk through like how Bolt works and where this Constraints API actually comes in. So here you can see a sequence diagram of how a user would request a pre-confirmation, and then how sort of the PBS pipeline would be made aware of this pre-confirmation and make sure that it's included in a block. So a user would send through an RPC or not a pre-conf request to a proposer. this proposer is running some software like the Bolt sidecar and a modified or extended mev-boost. So it will simulate and accept the request if it wants to issue a pre-confirmation and then send back a commitment to the user. And in the meanwhile, it will turn that commitment into a constraint that it can communicate downstream to the relay and then to the builders through some new endpoints. So we add a new communication channel from proposer to builders. And then the builder would sort of take a look at these constraints and build proofs. So build their block with these constraints in them, and then build proofs of constraint validity, so Merkle inclusion proofs, and attach it to their bids, which would also require like a new endpoint. So blocks with proofs, which would be a new endpoint where builders can submit these bids alongside with the proofs. The relay can then verify the proofs and the bid, and then once the proposer wants to propose a block, it can call get header with proofs, which is a modified endpoint, verify the proofs, and if the proofs are valid, sign the header and propose the block. And so it can sort of trustlessly figure out whether the block actually has all of the constraints in them or not. Cool. So in terms of how we chose to implement this, so the constraints API is sort of like a standalone out of protocol inclusion list. It doesn't really assume anything about the protocol that's using it. All it does is communicate constraints and then allow builders to generate proofs and proposers to sort of verify those proofs without revealing the full payload through Merkle inclusion proofs. Cool. Yeah, next steps, I'd like to go over all of the endpoints, the specific API, but maybe first, if there's already some questions, we can start there.
Yeah, I have a couple. I guess there's at least two, and perhaps the second one is simpler. So been kind of going backwards through the flow here. There's the call between the proposer and the relay with ETH v1 builder header with proofs. And yeah,
Correct.
I mean, this is maybe already going to be interesting, but we do trust the relays. And I guess it's an open question if we just want to go ahead and sort of put this under the closure of what we do trust the relay with. Because I guess one thing,
Yeah.
I mean, I also had this question with BuilderNet around latency, but we'll just put that to the side for now. And something I see here is just, yeah, thinking about, yeah, given how latency sensitive all of this stuff is, you know, the sort of more we can take off of the critical path, the better.
Yeah.
You know, I think in an ideal world, you would have the proofs just to like, again, reduce sort of the trusted base. But just a
Mhm.
comment, you could imagine like, okay, we do trust relays and relays usually work. And so you could imagine you just trust them to have satisfied the constraints. I do think it would make sense to send the constraints over, but then from there, you know, kind of everything downstream of that, you could just say like, okay, the relay in some way figures out, you know, how the builder is playing, you know, following the rules. And then separately, the validator would trust the relay to have done everything else.
Right. Yeah, that's I think a valid point. The reason we went with proofs was exactly to try to keep everything as trustless as possible, and also in a world where we might rely less on a relay. I don't know, like EPBS might come around. In this case, I think having proofs would also be useful because you don't really have anyone else to verify that the constraints were sort of valid. And if your concern is about latency, we do have some benchmarks. So on the builder side, generating these Merkle multi-proofs generally doesn't take longer than 5 to 10 milliseconds, which I think is okay, especially because there will be some point at which constraints will stop coming in. So the builder will have some time to sort of generate the proof and then submit that proof alongside to the relay. And then the relay proof verification, Alex, using your library takes like 20 microseconds. So I don't think that's an issue at all. Like unless, yeah, relays have think about it differently. But yeah, there is a case to be made that we. Sorry, go ahead.
Yeah, no, just a small comment here. Like, I think that this is interesting, and I definitely wouldn't write it off. But at the same time, for example, you said there is a certain point where the constraints stop coming in, and that's, I think, something that's quite dangerous to do. In that, if there is time to be gained by letting more pre-confirmations come in, building a more valuable block, then yeah, there's a good chance that people are going to try. And then if people are going to try, right, then you kind of get again these games where you try and maximize the amount of time. And then if you see that, wow, like having a little bit of extra time to have free comps come in, that's really valuable. Then you might start saying at some point, like, okay, maybe we can trust even more than the relay. And then you kind of get back to, maybe losing some of these. But I'm not saying I would write it off or anything like that. I think it could still work as is.
Right. Yeah. I think timing games are definitely a concern. What I would say against this is that the revenue from playing MEV timing games is probably going to be much more than the revenue from playing like pre-conf timing games, especially in the beginning. So I don't see this as like a major blocker, but it is something that we could take, yeah, definitely into account. Also, I just remembered another case why the proofs are actually useful, which is like in optimistic relaying. If the builder doesn't, if the relay doesn't decode the full payload, it doesn't have to. It can't look at the payload to see if the constraints are met, but it can verify the proofs, which generally doesn't take long. So there's already less that can go wrong.
Cool. And I mean, I guess there's always the sort of cop-out answer that the market will price it. If there is this like sort of intrinsic latency, it kind of back propagates through this whole system. And yeah, I know pricing pre-comps is like a whole different question, but yeah, ultimately sounds like it's worth building for like the less trusted thing and then seeing how it actually shapes up.
Right. I agree. And yeah, just to give more context about how we're using this specifically. So Bolt is just doing inclusion pre-comps. The way it works is they accept they make commitments up to a certain point in their block, in their slot. And after that point, it's really risky for them to issue more commitments because there's a chance, of course, that the builder doesn't get those constraints in time. So there's like a natural tendency for them to stop issuing commitments at a certain time. Because if the builder cannot come up with a valid block, then the proposer will fall back to a locally built block, which is much less profitable, on average than a PBS block.
Yeah, and I will say this does seem like it adds more pressures for co-location, which is not great, but I'll just leave that at that. Hasu, you have your hand up.
Yeah, so thank you for the presentation. I have a question. So is there any interactivity required between the proposer and the person they are delegating the pre-confirmations to? So when the gateway basically wants to make a commitment on behalf of the proposer, do they need to go back to the proposer and then back to the user, or do they have like the full authority to act on the proposer's behalf for the duration of that slot?
Right. Okay, so that's an interesting question. So generally, we leave delegation sort of out of the discussion of the constraints API. But the way that we do account for it is the fact that a proposer can authorize a different key pair to issue constraints on behalf of themselves that can, for the duration of an epoch or a slot, sort of issue constraints. The reason we add this is to account for the fact that people might delegate their pre-conf rights to other parties, like in the gateway design, but B, also that generally, like, you don't want to be signing things continually with your validator keys, so you can just authorize a different key pair to use like as a hot signer for issuing constraints. But we do so Hasu, to answer your question, the gateway can issue constraints on behalf of the proposer. And then it sort of becomes a question of whether the proposer still needs to enforce that all of the constraints are met, which I think is actually the difficulty of delegation. Like, it becomes much more subjective because the gateway can issue a commitment, but it can say, I assent the constraint to the proposer, so it should have seen it and should have verified the proofs. But there's no real evidence that like anything in that path can sort of go wrong. However, if the proposer directly issues these constraints, it knows exactly what it should verify. But yeah, we do support delegation in that way.
Right. Okay. Yeah. I mean, I'm trying to understand what is the latency requirements that is put on proposers here, right? Like how much communication is there required between a gateway and a proposer? What is the incentive for co-location between the two, right? We would love for a geographically decentralized validator actually to make, as much money as one that's maybe located in the US or in Europe when they use pre-confirmation. So I wonder how you're thinking about that. I mean, and of course, there's only like so much you can do through the design of your system, because if we have learned one thing from the rise of layer 2s, then it's that users just want faster confirmations, right? And so, I mean, this is one of the reasons why I'm interested in this to begin with, just because it seems inevitable, right? Like, so it's on us, not to prevent it, I think, but rather to make sure that we can design it so that really the co-location incentives are as minimal as possible. So yeah, sorry, my question was earlier in this rant, but if you don't remember it, let me know.
No, I think, yeah, how to decrease like co-location incentives and stuff like that. I think generally the way we try to, so there's been a lot of discussion about execution preconfs, which we fully agree like leads to a lot of centralizing issues because of latency races and all of that. We feel that starting with inclusion preconfs is probably the safest bet in order to test and try out these new things, because it's not that latency sensitive. Like you're not racing for an opportunity, you're just getting a faster notification of inclusion, which I think is a lot safer than already immediately starting to support execution preconfs. So like I fully agree with you that there is a lot of concern for co-location and latency races and all of that, but I think that's primarily in the execution preconfs domain, which we are kind of hesitant to implement at least some of the designs that are currently floating around, exactly because of that reason.
So the flow, when I'm a user and I have inclusion preconfs, I'm sending the request to the gateway, and the gateway asks it to the proposer, and it's just everything's happening. Is it somehow like throttled, or is it happening as fast as possible? And what if, for example, a wallet says, we want to have an SLA with this gateway that the responses should come within 1 second. So maybe not every proposer can actually satisfy that.
Right. Yeah. In the case of SLAs, like proposers, I think they should probably delegate their preconf issuance rights to someone like here, which would be the gateway. And then the proposer would still just be responsible for enforcing that the block that they propose adheres to all of the commitments made by this third party. As said before, like this does introduce subjectivity and a lot of sort of ambiguity, I would say. But we are definitely looking at various ways of implementing this. But yeah, I think delegation generally, especially with these things, like if you're expecting SLAs and stuff, I think it does make sense. But we just need to be careful in the way that we design it.
Okay, my very last question on the delegation. Sorry, did I cut someone off?
Oh yeah, no. Hi, Francesco here from Chamber. I just wanted to add one point on the delegation, which is that an interesting feature of inclusion pre-confirmation is the ability of potentially being able to delegate most of the duties to an RPC or a gateway while still retaining the signing at the proposer level. So building a sort of firewall approach that would decrease the bandwidth at the proposer level, decrease the risk in terms of having ports open and so on. And that's an avenue that we're exploring there, that both would potentially solve the subjectivity issue, because the commitment is ultimately signed by the proposer, and on top of that, decrease the risk levels and the overall risk on multiple dimensions at the proposer.
Okay, that makes sense. I wonder, Alex, this conversation about delegation, do you think that is satisfying with regards to minimizing co-location incentives for proposers?
Not really.
Oh, you mean me? Yeah, right.
Oh yeah, which Alex?
Oh, sorry.
Go
Yeah,
ahead,
if you're asking me, I mean, I don't think it's great, but at the same time, it's a permissionless protocol and this is happening. So, the next best thing we can do is harm mitigation, I suppose. Yeah. Like, I mean, I guess the other, like to play it out, it's like if mev-boost does not support pre-comps, then like they'll happen in some other way. And that's like one general argument for, this whole mev-boost PBS system in the first place is like, even if it's not like maybe the most preferable behavior, you still get to a place where things are more rather than less transparent. And, I think that's definitely where something happened.
All right, so if I understood correctly, like the main concerns that you guys have is about validator co-location, and them grouping around certain hotspots so they can issue like faster commitments and get more revenue because of latency.
Yeah, but I mean, bandwidth also came up where the concern is like, okay, let's say I'm a weaker node or a weaker validator in the network. And so out of the gates, like I don't even have the option to do this myself rather than delegate to a gateway. And so like from the very beginning, it's just like adding another actor like a relay. And that's, there's been a whole history of relay centralization and things that are not great. And then you have to think about censorship, and it just opens this whole can of worms of things that we've kind of had to deal with mev-boost to date. And yeah, I don't like it, but at the same time, I understand the UX benefits and sort of the demand for it. So, I think at the end of the day, it's just like I said, thinking about harm reduction and the best way to do this safely.
Got it.
Yeah. And I mean, just to background Alex Stokes, I mean, yeah, I have a very similar view. I've been initially very skeptical of pre-comps for the same reason, that I think they could drive significant co-location incentives for validators and increase, overall the cost of running a node. And that's why I think figuring out the right interface to enable full delegation, the way that it works today with block builders and relays, that to me is very important, right? So require minimal coordination between the validator and the gateway. Maybe even just delegating the authority one, something like that, for me would be the most satisfying under the constraints that we're kind of dealing with here from the market.
Okay, that makes sense. Just to add one more point here, like we have been running this on Oleski for a while. We have a public dashboard where you can check out resource usage, limited, I must say, like we show CPU usage, memory usage, but not bandwidth requirements. But we've designed it to be very low, like in terms of research usage. So if that's the only concern, then I think it could be slightly alleviated by the fact that it's that the process doesn't really use any a lot of CPU and memory. But I do hear the concerns about validator, like the co-location incentives, and I think makes sense for us to investigate delegation more seriously, just so we can reduce the incentives for co-location.
Yeah, I mean, the thing is, I'm like, is delegation even a silver bullet here? Because I think you get rid of maybe like infrastructure co-location with delegation, but then there's still the same question of like, okay, if everyone delegates to like the Bolt gateway, for example, uh,
Mm.
you end up with same, similar problems that we have with relays. And again, just to make an example, you could imagine that for some reason the Bolt gateway wants to start censoring pre-comps and or transactions, and yeah, it's not a great world to live in.
Right. Okay. Yeah. Interesting thing about inclusion precoms is that you can actually delegate to multiple gateways without them interfering with each other, because inclusion precoms are not conflicting. So you can have, I don't know, the ultrasound gateway potentially issuing precoms, Bolt gateway issuing precoms, both for the same slot. And so you can, yeah, you have more diverse set of operators that can sort of issue these commitments. So maybe that slightly alleviates the centralization concern, or at least the censorship resistance concern.
Yeah, it could. Ultrasound Alex had his hand up.
Yeah. Yeah, I'm just a bit curious if you see it the same way, that like we don't end up any worse than where we are today if we go forward with something like this and you have a delegation model, right? Like even if you suppose that the future is going to be something where blocks get built in this more piece by piece, transaction by transaction way, and maybe at some point that gets more and more integrated, um, then yeah, at least the way I'm imagining it, you still like there is stuff on the research roadmap that has everything to do with separating the proposing block building part out further.
Mhm.
And yeah, like is it a goal of this design to try and get the block building to be sort of more decentralized again, or is it also saying like, well, if we end up with the gateway and the relay and the builder sort of growing a little bit closer together, as long as we still have our proposer builder separation, we still have every proposer have equal access to this extra income, then it's all fine.
Sorry, could you repeat the question?
Yeah, if like, is it your intention that like this design for pre-confirmations forces things to happen on the proposer? Like you want the proposer to actively participate in pre-confirming, or is the design also fine with saying like, okay, if the market decides, or the implementations that are used in the wild decide that we prefer to delegate as a proposer and not be involved, then that's fine too.
Right.
Is that-
So, okay. Yeah, no, good question. So initially, we really did want the validator to run this because it sort of provides an additional lane to get your transaction included. That's maybe similar to an inclusion list, or at least a financialized inclusion list, where the validator regains some agency over the block construction process. Nothing related to MEV, at least for inclusion precoms, but at least like you can get your transaction in through the various validators instead of the couple of builders that are currently out there. But we did realize on speaking with other entities that delegation is something that they would desire, just because like operationally it's easier, and you keep the plausible deniability that PBS sort of offers you. So we would, if we decide to go with delegation, like we've been already working on some designs, but we'd like to be very active in finding a design that doesn't add too many trust assumptions and centralization vectors. Like we're not going to go against the market, but we're going to try to, if the market guides us that way, at least design something that's like credible and minimally harmful.
I did have another question from the very beginning, because there was the one piece that we talked about with this question of like, if we trust relays, do they really need to verify proofs on the back end of this whole pipeline? The other thing I was curious about is if you could expand a bit on the very beginning, where the gateway sends essentially these requests to the proposer. And yeah, I mean, part of this is I've looked a lot more at the let's say delegation mode of this, where the gateway handles everything. But then in the world where the proposer then is like much more active in this, how does it look like? Is it like a lot of overhead or resource demand on that node. I think it was like the simulate and assess pre-comps or something label on the chart that you had.
Yeah, exactly. So the only thing you need to do is make sure you don't commit to a transaction that's invalid according to like protocol rules. So you validate balance, nonce, base fee, and all of that. And then you decide whether the priority fee included is actually enough for you to make this commitment. And that's about, and then yeah, you make the commitment and you turn it into a constraint and you store that locally. And when it's time to propose, you actually submit, or close to the time you need to propose, you submit all of those constraints to the builders, and you verify the proofs, and that's about it. And if the proofs fail, you have this locally stored block that you can propose instead. So you don't make any like commitment faults because PBS because of a PBS fault or whatever.
Right.
But in terms of
And,
resource use, in terms of resource usage, I think I hope the dashboard that I shared is helpful. It's actually currently pre-confirming stuff all the time, so it should be sort of representative. But we can add more data if you'd be interested.
is that with the gateway or no?
No, that's the proposer actually receiving pre-cons directly.
I see. And so, yeah, I guess one proposal would be to add that functionality to mev-boost, or is there like a different piece of software that handles that part of the pipeline?
Yeah, so that's a bit of an open question. Right now, it's a different piece of software that handles that because it is it is a lot that needs to be done, and I don't know if upstreaming everything into mev-boost makes sense. So I think the discussion here should be more like, can we implement the constraints API or some version of it in the future that becomes a standard inside of mev-boost, so that other sidecars like this can communicate with builders to send constraints.
Right. And the software right now that has like an active connection to the local EL.
Right, that's the with us it's called the Bolt sidecar.
Okay. But I am just trying to like connect all the pieces, because like the way I understood it is that I get a pre-conf request as a proposer. I then need to verify that the transaction is valid, and then yeah, essentially if I went to like sign off on the pre-conf. And so I guess the reason I'm bringing this up is like, so far how we think about all this is that like mev-boost, for example, doesn't talk to the EL at all. It doesn't really need to, because that's all handled by the
Right.
relay. And so that's like, it's not impossible, but it is somewhat, well, let's just say it's a non-trivial ask to have, say, mev-boost reach out into the EL as well.
Right. Well, it still wouldn't need to do that. That would be dealt with by the Bolt sidecar.
Sure, but whoever does it, it's like someone will need to do it. Yeah, so okay, maybe that's fine. I guess then the question is like, I'm now running another binary, and that's a different type of ask. Just like in terms of
Yeah.
DevOps to like run all the software.
Yeah, absolutely. I agree. I think that's going to be the biggest lift. But like to give you an overview of how this would look like simplified on the proposer side is you'd have your validator client, a beacon node, and then you would point your builder API to the Bolt sidecar, and the Bolt sidecar would then communicate with mev-boost over the constraints API. And in most cases, the Bolt sidecar is just a proxy for all of the builder API requests, but it can also intercept some of them to like verify the proofs, etc. And so users send commitments, Bolt sidecar turns that into constraints, and then submits that over the modified mev-boost.
Right. And maybe just to close the loop, it's like moving to this world, there's now like another sort of thing to think about conceptually for people who like test and secure the protocol. When things go wrong, it's like, relays are available to like address issues. There's now just like more actors to keep track of, which doesn't excite me, but I understand what's happening.
Right.
Yeah.
I mean, yeah, the other approach is you just do full delegation. You delegate everything to a relay, to a builder, and you can just run your vanilla mev-boost. I don't think that's a great idea because of all of the subjectivity and centralization issues that delegating ahead of time, like full delegation, sort of gives you. But it is another option. I just don't think it's the right one.
Yeah, makes sense. Alex or Chris, you both have.
About like how you think about inclusion, like some transactions you can imagine are a bit contentious, and maybe they'll get included, but then when the builder gets them, they'll still want to execute them in a way where they don't work out or get reverted or something like that. Would that just be like the user's kind of responsibility, where I can expect a pre-confirmation on a simple ETH send to always go through, but I know that if I'm doing something more contentious, like a swap or something, or I don't know, trying to execute a liquidation, that I know that if I get a pre-confirmation, that maybe in the end it ends up like not included but not executed? Like, how do you think about that? What is safe to pre-confirm or not to pre-confirm, or whose responsibility is it to make sure that this works out, right?
Yeah, I think initially we can put some of that functionality in like any RPC or any intermediary that sort of filters these requests. But if we don't want to add that complexity, then it should just be on the user to not send contentious transactions to this new transaction lane, because you probably either get the worst price or just get reverted.
Yeah. And maybe then a quick follow-up question. Do you think it's like reasonable to expect that then maybe that gateway starts very quickly integrating with the builder because they do want to make sure that they can include or not include, and sort of smush together that way?
Yeah. Wait, so you mean like if a transaction comes in, they integrate with the builder so they can validate that it's like a contentious transaction?
If you want to be really good at giving pre-confirmations that actually go through as a gateway, then I guess it would start being in your interest to talk to builders to see, like, do you think that you would include this at the given price in a way that actually executes or makes sense?
Right, but then it does start to look a lot like execution
pre-confirmation. Fair.
More, because like there's no with inclusion preconfs, there's no guarantee about the execution, right? So the builder that you send your contentious inclusion preconf to, they can just include it wherever, which may or may not get you the best price depending on which builder or which rules that they're following. Yeah, Chris.
One thought was that one downside of like pre-conf that go directly between user and the proposer is that the proposer needs to be publicly accessible for like the first time.
Right.
And that can pose like some security concerns where delegation might be beneficial to keep the proposer still firewalled from direct public access.
Yes, I agree. And that's like the first level of, we call it delegation that we explore, where the proposer sidecar doesn't have to expose anything anymore. Instead, it subscribes to some RPC, which could be a gateway or not. And it's an outbound connection, so they just make a subscription. They don't have to expose anything. And then the Bolt RPC or whatever intermediary sends them all of the validated inclusion requests, and they are just in charge of committing to the ones that they want to commit to, and then making sure, obviously, that the block they propose adheres to all of these constraints. But in this way, you sort of get the best of both worlds in that a lot of the duties are outsourced to this sort of firewall, but you are still, like, as a proposer, you're still in charge of which commitments you make, and then you're also responsible for enforcing those commitments. So there's no ambiguity there.
An interesting extension of this could be to put this into TEEs. So the proposer could request TEE proofs to the endpoints it connects to for pre-conf delegation. So the route could be like more or less a trustless and verifiable setup there too.
Yeah, I think exactly. I think on the TE side and on the builder end side, there's a lot that we can we can do because of these new security assumptions. I think it maybe opens up more doors towards full delegation that is not as insecure as just trusting an entity, because now you get this integrity and verifiability.
Okay. Yeah, thanks for the overview and answering all of our questions. There are many.
You are welcome.
Yeah. I mean, I guess to move forward from here, yeah, I mean, would there be concrete proposals to add these different things to mev-boost, like, adding the constraints API, or like even this more full-blown integration with the proposer being the actual pre-confer?
Yes, so community is currently still sort of settling on a version of the API that everyone would be fine with. I think that's gonna still take a little bit of time, but in the meanwhile, we do have this version out already that people can start to take a look at. I'm gonna send some links in the chat. Well, formatting is really bad, but these links should contain enough information to get you started. And we do have reference implementations, which we also plan to do for any changes that might come up because of the discussions with other teams. And then when there's rough consensus on like a specific API standard, I think it'd be good to do another call, maybe present the full API, and then see if there's room for upstreaming that.
Okay, yeah, that makes sense. Maybe just a few low-level questions here. So there's a call out to like a relay reference impl. Is that like the gateway in the pre-conf world, or like would there be any
No.
changes required for the mev-boost relay today?
Yes, they would need to relay these constraints that they receive from proposers to builders. They would need to implement the endpoints to do that, and they need to implement like proof verification on the blocks.
Okay, so even if we are in a world where there's only gateways and like everyone delegates their pre-comps, you would still need relay changes.
I think in most scenarios, yes.
Okay.
But that's actually a good question. I'll try to look into that.
Okay. Have we thought about how this interacts with optimistic relaying at all?
Yeah, the proofs field is useful in the case of optimistic relaying because you don't need to look inside the payload to verify the constraints. You can just verify the proofs. And since that doesn't really take long, it should be okay to do in the hot path.
Right. And so how does the world look like if mev-boost doesn't change at all? And let's assume people want to use pre-comps. They would then just run the bolt sidecar.
Right. If mev-boost doesn't change and relays and builders do, or if just
let's think about that.
Right. So I think in that case, there's two options. Either the bolt sidecar itself becomes sort of integrates sort of a mev-boost like thing where they speak directly to the relays and maybe bypass mev-boost, or there is the commit boost module that sort of implements this, and people run that. But of course, like we can't tell what people would prefer to run. However, that's like on a technical level how we could move forward.
Okay. Yeah, thanks. So yeah, anyone who's listening, it sounds like there's some work to do. Is there like timing here? Like, I guess, I know there's been work on the test nets. Is there like a deadline of sorts, or like, assuming we put these changes into mev-boost, like, is there a place or a time we should be aiming for?
That's a tough question. I think like first step is going to be agreeing with the community, and I think that's going to take a long time, or at least some time. So I wouldn't say there's necessarily pressure yet, but as soon as we know more, we'll definitely reach out to everyone involved. And we're also very happy to take the lead in like providing reference implementations and stuff like that.
Okay. And when you say community agreement, you mean around like standardizing these APIs, or more generally like, you know, if people adopt this thing at L1?
No, I meant standardizing the APIs with other pre-conf teams that may also need this.
Right. Okay, cool. Thank you.
Awesome. Welcome.
Any other questions from anyone? Otherwise, I think there is one more thing I wanted to bring up on the agenda. Cool. Okay, so the next thing then was the gas limit. This is really just a call out for any relays listening, just to verify, I mean, builders as well. Anyone in this pipeline should like triple check that they handle gas limits correctly. There's been a lot of activity lately from the community broadly to think about raising the L1 gas limit. You know, generally, yeah, I mean, we probably should raise the gas limit, so it's happening. The question is like when, and in any case, some of the core devs on the CL and EL side have started looking into this and have found a number of things that aren't blockers, but just like subtleties around how they handle gas limits across all the different software. And yeah, the call out for relays in particular, but also builders, is just verify that you are handling this correctly. So maybe for a quick refresher, a proposer will send their preferred gas limit into the mev-boost system as a validator registration. And then the idea then is that the relay verifies this and the builder should respect it when they're building blocks on behalf of the proposer. There is like a little subtlety here because, you know, say I set my gas limit to like 40 million, but say the mainnet, you know, limit right now is say 30 million. Like as you bridge this gap, there's like protocol constraints on how quickly the gas limit can change. And so in this case, for example, if the builder had the situation, they would need to respect these protocol limits, which if I remember correctly, you know, can only change 1/124th per block. And so then, you know, even if the validator says, hey, I want a 40 million gas block, if we're only at 30 million, they can only go so far. So yeah, there have been bugs here in the past in this stack, and, you know, hopefully they've all been resolved. But again, just a call out because I'm trying to get ahead of any potential issues as we start raising the gas limits. And it should be fine, but if again, everyone can triple check they handle this correctly, it will reduce some headaches in the future. So I think that was my spiel on that. Are there any questions?
No, just maybe that you're already too late. We already hit like first issue that we saw around this, but yeah, in the end, it turned out not even that related. It was definitely triggered by people changing their requested gas limit. I guess we'll keep working out issues, but so far so good. People get demoted as they should when they don't send correct blocks.
Okay, awesome. Yeah. So if anything, I'm just calling this out because it's going to be something on your desk soon. So have it top of mind. And otherwise, I think that was it for the day. If there are any, closing comments, otherwise we could wrap up a little bit early.
Yeah, maybe a small one, like Ultrasound is actively exploring supporting node operators a bit more intently. So the people running lots of Ethereum proposers. If you happen to be a node operator listening to this call and it's interesting to you, then you can definitely reach out to me, Smiling Alex on Telegram.
What does it mean to support a bit more? Now I'm curious.
We have a lot of stuff on our roadmap, but it seems like we're at a point where we run pretty steady, but we think there's still a lot we can do if we're also like working more closely with what an operator is doing on their side. Can I give another concrete example? We just had an issue with one of the operators that was far away, where how they had their deadline set was very influential for whether we were going to miss a slot with them or not. Like these are all things where now there's still very little communication, but I think if we can communicate more, maybe also support each other a bit more directly, then that could be better for both of us.
Cool, thanks. Okay, anything else? Okay, then I'll call it. Thanks, everyone. Enjoy the rest of your year and the holiday season, and I'll see you next year.
Thanks,
Thank
everyone.
you. Bye.